This is the first of two lectures on the methods that are used in psychology to investigate human behavior. These methods include quantitative methods from which you get data that add up into numbers and for which you can do statistics, but also qualitative methods where the data are not quite so clear. So we're going to talk about both of those over this two-lecture series. Today it's going to be specifically on experimentation, which is definitely a quantitative method in psychology. But first I'd like to step back a minute and ask the question whether psychology is indeed a science, because we're claiming to use scientific methodologies here. And when I ask my students that, sometimes, now I teach in a university where we have a lot of engineers and a lot of hard scientists, and they sort of get a smirk on their face and say, well, psychology can never be a legitimate science after all. How can you possibly predict an individual's behavior? You can't do that. I can predict the behavior of a block on an inclined plane, or the chemists say when we add two chemicals together, I can predict the behavior. You can never predict the behavior of an individual. So how are you going to do that? How's this ever going to be a science? And then I try to convince them that indeed we can look at human behavior. It is true that for a single individual, we can't predict their behavior except in a probabilistic sense. We can predict it that way. We can't deterministically say how the person is going to behave. But you also discover in some of the other sciences with chaos theory and other kinds of theories, they can't exactly predict what the state of that atom is going to be either, except in a probabilistic sense. And nobody accuses the physicists of not being scientific. So I like to try to convince them that in fact psychology is the most sophisticated of the sciences, because we do have to deal with human variability in what we do. And much of what I'm going to talk about today with the experimental method is dealing somehow with variability in the sort of more naturalistic setting that psychologists have to work with, rather than the setting that the hard scientists, so-called hard scientists, have to deal with. And psychology has come up with some very sophisticated statistical ways of dealing with this variability as well. What is a science exactly? Well, if you ask people that, most of them say, well, it's kind of a collection of facts. That's true. It's kind of a more organized collection of facts. And those facts are usually a relationship between variables. And usually that relationship is between a set of circumstances and a particular behavior. If you're a chemist, you want to know the circumstances of putting this chemical at this particular temperature and this particular purity in with another chemical, and what happens, what's the behavior when that happens. If you're a physicist, you might want to know you have this block on an inclined plane and at a particular angle and a particular surface on the plane, a particular mass of the block, what's the behavior? What's the relationship of that set of circumstances to behaviors? And in psychology, we're no different. We're just looking at human behavior, and we're trying to say what are the circumstances that lead to a particular behavior. And the best kind of statement we can make is not only that the circumstances are related to the behavior, but in fact the circumstances cause the behavior. And the nice thing about experimentation that we're going to spend this lecture talking about is the fact that it is one of the scientific methods that can be used to say one thing caused something else. And I hope I convince you of that today. It's a very powerful kind of tool, experimentation is. Not the only tool in science, as we will see. It's difficult, for example, for an astronomer to do experimentation. You can't move this planet from here to here to see what happens. And so very often they cannot do experiments. They can do little experiments, but typically they can't do the big experiments that would be necessary. So there are other techniques in science, and we're going to talk about some of those other techniques in the next lecture. But today we want to talk about experimentation. Now, when I do this in my class, what I typically do is say, okay, in order to understand experimentation, I think the best way is for me to make you an experimental psychologist. So I hereby declare that you're an experimental psychologist. And now, pretend I work for the government and I have millions of dollars to solve a particular behavior problem. And what I want you to do is propose a way of solving this problem. You're now a researcher, and I want you to solve this problem. And the question is, does violence on TV cause aggression in children? Now, this is actually kind of an old problem in psychology. This has been studied for some 40 or so years in psychology, but pretend this is the first time you ever heard it. Does violence on TV cause aggression in children? And I don't want your opinion about this, and I don't want you to collect other people's opinion about this. What I want you to do is figure out a way of doing some research, collecting some data that will help convince me that yes, it does, or no, it doesn't. Because what the government wants, of course, is I got this money from the legislature, and they want to go back and look at Saturday morning programs for kids, and they want to look at what kids are watching on television, and they're concerned about shootings in schools and things like that. So they want to know whether the violence on television is a contributing factor to this kind of behavior. So that's the purpose of this kind of thing. So I want you to sit and think about this problem and come up with a solution. That's what I tell my students. And then I give them 5 minutes or so to do this rather artificial situation. And they talk amongst themselves. And then I say, okay, what have you come up with? What kinds of research are you going to do? And I'll tell you sort of the general kind of research they suggest. Well, Dr. Martin, what we're going to do is we're going to go out and sample a whole bunch of kids and bring them in and have them watch TV shows. And they're going to sit and watch the TV show for an hour a day, and we'll do this for about a month, and then we'll observe their behavior. And one group of kids is going to watch violent TV and come in and watch that an hour a day for a month, and the other group is going to come in and watch nonviolent TV for an hour a day for a month, and then we're going to put them in a room and we're going to observe them and see who's more aggressive. And that's our solution. That's the typical situation that the student comes up with. Now that's good in some respects. They have created an experiment indeed, and they have all the requirements for that experiment, at least superficially, but in some respects, they haven't dealt with a whole lot of questions that you need to deal with before you do an experiment. So let's talk about some of those questions. I ask them, well, you just said you're going to show them violent TV shows. What does that mean? How do you know violence on TV when you see it? Well, we know some shows are violent. I mean, the CSI is violent maybe, and the shoot-'em-up kind of shows are violent, and I know that when I see it. We'll just pick out the violent ones and the non-violent ones. I say, well, that's not quite good enough. You see, if somebody wanted to repeat this experiment sometime in the future or validate it, see whether you did it right, they would have to know how you define violence on TV, so they could define it the same way. And in fact, what they need is what's called an operational definition of violence. What operations would you go through to try to define violence? Well, let's see. How about, let's make a list of things that are violent. If somebody hits somebody else, that's violent. Okay, we'll write that down on the list. That's part of our definition. If somebody hits somebody else. If somebody insults somebody else, that's violence. Okay, we'll write that. If there's blood involved, that's violence. Okay, we'll write that. If death is involved, we'll write that. So we could write down a whole big long list and operationally define violence that way. And every time we saw a TV show, go over that list to see how many of those. Maybe you need 4 out of the 10 things on the list to make it a violent show. That would be an operational definition. However, there's still some subjective judgment involved in terms of looking at the show and trying to decide whether the list was appropriate, and there might be some question about some of the things. For example, is NFL football, is that violent? People hit each other, don't they? That's on the, blood's involved sometimes, right? So we can check that off. But is it really violence? It's certainly violence within a very socially accepted version of violence. And these people are allowed to behave this way and not scorned. In fact, they're rewarded quite nicely for behaving this way. What about Roadrunner cartoons? You got Wile E. Coyote chasing the Roadrunner around off a cliff and that sort of thing. People, they never seem to die for some reason after falling off these big cliffs, but there's certainly a lot of hitting and violence involved in that. But these aren't really humans either, are they? And in fact, the whole point is humor, not a more serious kind of point. So there may be problems with this. Another way that they could operationally define it is to bring together, say, a group of 100 people that you would pick. You would show them 10 minutes of one of these shows and then have them rate the show. Just use their human judgment, whatever their internal definition of violence is. If this is a 10, it's the most violent thing you've ever seen. If this is a 0, that's the least violent thing that you've ever seen. And we could operationally define it that way. At least that way, the next person could do the same thing. Bring together another group of 100 people, show them the TV show, and have them rated in much the same manner. So that's at least a nice operational definition that way. So you got to be kind of careful what you're doing when you look at violence, but you have to be careful on the aggression side too. These people kind of blithely said, well, we're going to observe them and see how aggressive they are. Well, how do you define aggression? Same kind of problem. You need an operational definition. And again, you could make up the list. Whenever Johnny hits Susie, that's aggression. If Johnny's saying nasty things to Susie, that's aggression, and so forth. So we could make another list up that way. What they want to do, of course, is hire a psychologist to tell them whether or not it's aggressive behavior. But psychologists don't have any magic answers either to these kinds of things. So there are a number of ways you could measure this. So one way that's often suggested is, let's take a group of toys, and we'll have aggressive toys and non-aggressive toys. So in the aggressive toys, we got play guns and play knives and tanks and that sort of thing. In the non-aggressive toys, we got dolls and we got trucks and we got tractors and we got those kinds of things. So we'll put out these toys and let them pick and choose what they're going to play with, and see whether they play with the aggressive toys or the non-aggressive toys. Sounds like a good idea, perhaps, although one might be able to argue that they're just imitating. And if they just saw a violent TV show with guns and knives, they know how to use those. Maybe they don't really know quite how to use the truck and the tractor as well if they're watching nonviolent. So maybe they're just imitating. They're not really being aggressive as they do this. So there may be problems with it, but at least that would give us a nice quantitative measure of behavior. And we could argue one way or another whether the operational definition was a good one. Also, one of the problems is, how do you know a representative sample when you get one? These people are concerned with, the students are, because they often say, well, we want to make sure that we get people from different socioeconomic classes. We want to make sure we get people from different amounts of violence in the home or aggression in the home, from different ethnic groups and so forth. So we want a representative group somehow, but they don't know quite how to do that, whether they can randomize it or whether they can do something else. And so that's also a concern that often comes up here. So that's what they do in this little exercise I give them. And what I'd like to do now is go to kind of a model of an experiment and see how this little exercise we just did fits into that model. And this model will allow us to look at causal relationships because it's an experiment. Imagine on the left that we have a whole list of circumstances that we might be able to vary. And those circumstances can be all sorts of things, anything that might go into this kind of experiment. Now we know one that's going to go in there, and that's violence versus nonviolence, because that's part of our question. So we know we want that to be a particular circumstance. But there are other circumstances as well that we have to decide on and what to do with those circumstances. Things like, what size TV set are we going to use? Or what's the children's age that we're going to use? What's the group size? How many kids are we going to have watching this TV set? What's the room size? How many sessions are we going to have? What's the length of a session? How much TV are they going to watch? What day of the week? What's the socioeconomic status of the kids? And so forth. We could make a list, essentially, of an infinite list of circumstances over on the left side. And what we want to do, remember, with science is relate the circumstances to behaviors. And so over on the other side, we have all sorts of behaviors that we could potentially measure. Now, in our case, since the question had to do with aggression, we would know kind of what we would want to measure, things like what toys do they play with or something like that. But there are all sorts of other behaviors that are going on here as well, such as how many hitting incidents there are, what the noise in the room is, how often they go to the bathroom. We could measure all sorts of different kinds of things that are all behaviors on the behavior side. And what we want to do with our science is relate this set of circumstances on the left side to the behaviors on the right side, and we can draw an arrow across to indicate that that's the rule or the law that we're looking for, that's the relationship, and it would be a causal relationship between the circumstances and behaviors. Now, in order to turn this into an experiment, we need to partition out the circumstances and pick a behavior. So let's pick a circumstance of interest. It's already been picked by our question, violence on TV. And the folks I asked this, even though they weren't professional psychologists, knew sort of immediately that they had to have at least 2 levels of that. So they have to have violent TV and nonviolent TV, minimally. They could have other levels as well. They could have it's kind of a neutral level, or they could have a no TV level, or they could have other kinds of levels as well. But they have to have at least 2. After all, if I just showed you violent TV and had no other group and measured the behavior, and I said, oh, these people are pretty aggressive, it must be due to the violent TV, you could rightly come to me and say, well, how do you know? Maybe they'd be just as aggressive if they'd never seen your TV show, and you'd be absolutely right. So we know we have to have at least 2 levels. Sometimes those are called the control group or the control level and the experimental group. Now, those are useful sometimes when you have a particular treatment, but in this case, just having violent versus nonviolent, it's really doesn't make much sense to call one a control group and one an experimental group. But we need 2 levels. So we pick that and we manipulate that, and we call that the independent variable. So the circumstance we pick to manipulate at least 2 levels is called the independent variable. It's called independent variable because it's independent of anything that the subject or the participant might do in the experiment. All right, they can't come in and say, I want to watch the violent TV, because we assign them to that. They don't have any choice over it. It's independent of their own behavior. On the other side, we have to pick at least one behavior to measure. We already talked about that a little bit. Are we going to, the proportion of toys that they play with, or the number of hitting incidents, or what exactly are we going to measure? Let's assume we've at least operationally defined it and picked one behavior. And that's called the dependent variable. The dependent variable is called that because it's ostensibly dependent upon the levels of the independent variable. Okay? So we've now picked a dependent variable as well. On the behavior side, we can ignore the other behaviors, essentially. We can't do that on the circumstances side. We have all of these other circumstances here that we can't just ignore. And so what are we going to do with those circumstances? What immediately comes to mind for most people is, well, let's set them at a particular level and not allow them to vary. All right, so they're all going to watch the same size TV set. They're all going to watch it in the same size group, let's say 6 kids watching it, in the same size room, at the same time of day. Let's just set everything else and make them all what are called control variables. A control variable is a variable you set at a particular level and you don't allow it to vary during the experiment. And indeed, that's what's done for the most part in the hard sciences. They set up lots of control variables. So the chemist wants to make sure the temperature is the same and the purity is the same and the particular composition is the same. They set up lots of control variables. We set up some control variables in psychology, but there's a problem. The first problem is we couldn't possibly set all of them up as control variables. For example, there are differences between the kids, right? And we're not allowed to clone kids for experiments. We might like to do that, but we can't do it. And so we have to get what we can take in terms of kids. And we can't say, okay, the weather is going to be perfect for all of these experiments. The weather changes, and there's nothing we can do about it. And lots of different kinds of things change that we don't have much control over. So we can't set up everything as a control variable. And frankly, we wouldn't want to if we could. Because if we set everything up as a control variable, we wouldn't be able to generalize our results to anything. Suppose we could set everything up. And so we set up this experiment, and we picked only kids in St. Louis, from a particular community in St. Louis, whose parents make between $30,000 and $32,000 a year, who are from a particular ethnic group, and all of these control variables that we've set at a particular level. And then we finish our experiment, and I said, I've got your answer for you. Violence on TV causes aggression in kids. Somebody might say, well, that's great. Can we go use this? And well, wait a minute. It only works in St. Louis, for kids from this community whose parents make this amount of money. Say, wait a minute, that's not what I wanted to know. I wanted to know in general, does violence in TV cause aggression in kids? So you couldn't generalize it to the whole population you were interested in. And that's why you don't want to make everything into a control variable, even if you could. Another option is to make it into a random variable. And random variables save psychologists' career. Because a random variable, you just, as long as you do things in a random fashion, and that's not always easy, you have to make sure it is a random fashion. If you're picking the group of kids to use, you have to put all the names in a hat and draw them out individually, or at least do so maybe on a computer, where you put all the names in there and randomly pick them out. And then you hope that randomization works, and it usually does for large enough numbers at least. Suppose we're using 100 kids here, and you pick one for the violent TV group and one for the nonviolent TV group. You would expect that on average, you're not going to get all of them in the violent group coming from highly aggressive homes, for example, where with highly punitive behavior, let's say, and all of the ones in the other group from non-aggressive homes. On average, they're going to have about the same number, and they're going to come from about the same socioeconomic class, about the same ethnicity, and so if it's truly randomly selected. So a number of these variables we can partition and call random variables. And that gives us a lot of power. Not quite as much precision, but it gives us the ability to generalize to other populations. All right, a variable we want to be very careful about is what's called a confounding variable. We don't want any of our circumstances to come up to be confounding variables. Now, a confounding variable is a variable that changes along with the levels of the independent variable, usually accidentally. We usually don't know that's happening. And that may not make much sense. Let me illustrate it within our situation. Suppose you were running the violent TV group and the nonviolent TV group, and you looked around for TV shows, and the way you defined it, you had a dickens of a time finding anything that was nonviolent, because in fact most TV shows are fairly violent. And so in fact all you can find for your month-long experiment, if you're showing TV to the kids every day, is about 4 hours of violent TV, but you can only find 2 hours of nonviolent TV. And so you set up your experiment that way, and you run 4 hours of violent TV, and the nonviolent folks watch only 2 hours. And you do your experiment, and you find that violence on TV causes aggression in children. And you say, that's our conclusion, you write it up in the report. Somebody could step in very easily and say, now wait a minute, Dr. Martin, I don't think you showed that at all. I think what you showed was that the more TV they watch, the more aggressive they are. And it's 4 hours versus 2 hours, rather than violent versus nonviolent. And they would be absolutely right. And I would have no defense against that. I'd say, okay, you're right, it could be that. And that would sort of have killed my experiment, wouldn't it? Now, I probably wouldn't be quite so stupid as that. Suppose instead that I did show 4 hours to each of the groups, and I write up my report, and my lab assistant comes in when this is done and says, you know, Dr. Martin, you weren't there. I was there while they were watching TV. And those kids watching the violent TV, boy, were they engrossed in that TV show. Probably 80% of the time their eyes were on that TV set. They thought it was great. I watched the nonviolent kids, the kids are watching the nonviolent show too. And they probably weren't making eye contact more than 20% of the time with the TV. They were off doing something else most of the time. That bored them to death. So in fact, one group was watching a lot more TV than the other group. And I said, I can't believe we let that happen. We got a confounding variable here, don't we? You go back in there and make those kids watch the TV show. Okay, every time they turn away from it, you yell at them, slap them upside the head, you do whatever's necessary to get them to watch that TV show. And so then we run the experiment. You can imagine how it's going to come out now. Probably the nonviolent group's going to be more aggressive than the other group because of all the pressure we put on them. You see what the problem is we have a confounding variable again in there. And in real-world experiments, it's sometimes very difficult to get rid of confounding variables. Let me give you another example of a confounding variable from a real experiment I did a number of years ago. A graduate student in educational psychology and I decided to do an experiment looking at lecture pace and looking at attentiveness of students as a function of lecture pace for my class. And I had a class of about 200 intro psych students out there. They're sitting at tables in chairs taking notes. And I would come in, and some days I would lecture at a very slow pace, much like this, where I had lots of spaces between my words. They thought I was hungover when I did this, but nevertheless I did this. I came in some days, and for a 10-minute period of time, I would lecture at a fairly medium pace, much like I'm doing now. And some days I'd come in and I'd just go gangbusters, just talking about like I am now. And I'd do that again for 10 minutes, and we would measure my pace and go measure the number of syllables per minute to make sure I was producing the right pace. And then we would measure ambient noise level of the students in the room. We measured some other things as well, but one of the more important ones, we measured ambient noise level and subtracted out my particular noise that I was making up there at the podium. And when they're more attentive, the idea is they're quieter. When they're not being attentive, they're rustling around their papers and dropping their pencils and talking to each other and that sort of thing. So we measured the ambient noise level. And what we found, and reported in the literature, in fact, if you graphed noise level as a function of low, medium, and high pace, we found kind of a V-shaped function. And that's good, because what it says is they're most attentive when I'm speaking at a medium pace. If I'm speaking at the low pace, they make more noise. If I'm speaking at the high pace, they make more noise. So that was kind of a good result that we got. And we're proud of that. It was reported in the literature. But I might point out that there are potential confounding variables in that. When I speak at a low pace, much like most people, my voice is fairly low. As I speak a little faster, the tone of my voice, the fundamental frequency goes up, and when I speak fast, my voice is way up here. So in fact, if you wanted to plot along the bottom instead of low, medium, and fast pace, you could plot low, medium, and high fundamental frequency of my voice. And there's no way, short of recording it and speech clipping and doing some other kinds of things, which would be very artificial, to make it go any other way. So naturally, I had a confounding variable. I also had a confounding variable in terms of how many words I used to talk about a concept. Either I would make the concepts come quicker, or I would use more words to talk about the same concept. And so one of those had to naturally vary, and that was another confounding variable. So when you do real-world experiments, like violence on TV, you often get naturally occurring confounding variables. But it's very important to realize that there are confounding variables, if there are, and be able to have alternative explanations for those confounding variables. Now, I might point out again, as I did early on here, that the real beauty of experimentation here is the fact that you can make a causal statement. We've just all agreed in science that if you do manipulate an independent variable, where the experimenter manipulates it and you don't let the participant mess with your independent variable, and measure a dependent variable, and you do control your control variables, and you do legitimately randomize your random variables, and you don't have a confounding variable, if you follow all those rules, then we agree in science that you can attribute the change in behavior to the levels of the independent variable. A very powerful thing, a causal statement. And it's kind of an agreement that we all have. It seems to work is the main reason we can agree that that's the case. So this is the only real technique we have where one piece of research will show a causal relationship between a set of circumstances and behaviors. And that makes it a very powerful technique for methodologies in psychology. Next time we'll talk about some techniques that aren't quite so powerful, but are also used in psychology. Thank you.